Hi, this is Mr. Manley, and this is a non-square three-variable linear system. Non-square means that instead of three equations with all three variables, one of the equations, at least one of the equations, is missing one of the variables. Here we have a system where each of the equations is missing one of the variables. The approach to this is the same as with a three-variable, three-equation system. I'm going to try and combine two of the equations to eliminate one of the variables. In this case, I'm going to eliminate the variable x by combining equation 1 and 3. Notice that when I do this problem, I number the equations. This helps me keep track of my work. These were not initially numbered 1, 2, and 3. I put those numbers there. And then when I look here, if anybody were to look at my work, they might be able to infer that I was combining equation 1 and 3. I am going to eliminate the x variable, so that means multiplying the first equation by 4. And I don't have to do anything to the second equation. I put an x here when I should have put a y, so that should be a y. Now I'm going to eliminate the x, as I promised, by subtracting the equations. 4x minus 4x is 0x. 12y minus a negative 3z. That is going to come out to 12y plus 3z. And then 4, don't forget the minus, 4 minus 13, negative 11. Look at this result, and I've got y and z. Look at equation 2, has y and z. That will be where we combine next. I'm going to say 2 and 1 and 3. This notation that I'm using isn't critical, but it helps me keep track of my work, so I know what I'm doing from step to step. I can look back at my work and see what I did from step to step. Combining these two equations, I got the 12y and the negative 2y. So I'm going to multiply this equation number 2 by 6, so that I will have I'll be able to eliminate the y term. That would be negative 12y when I multiply this equation by 6, minus 12y minus 6z is equal to 6, and 12y plus 3z is equal to negative 11. And we've got negative 12y plus 12y, that's 0. We're adding these, notice. And then negative 6z plus 3z will give us negative 3z. And 6 minus 11, that does not seem right. Yes, I made an error back here. That negative 11, 4 minus 13, that would be negative 9. So let's fix those up. That'll be negative 9 here, and we'll have negative 9 over here, and that'll be negative 3. So z equals 1. Now remember what we're trying to do here. We're trying to solve this system, which a system is when we have more than one equation and we're trying to figure out is there any value that will satisfy all of the equations, or any set of coordinates that will satisfy all the equations. So we're looking for a set of coordinates x, y, and z, and we have just found z. So we found the first number of the coordinates that satisfies all three equations. All right, so I've got z, and then you can look here and look. I could put z here and then solve for x, or I could put z here and solve for y. So let's go ahead and I guess I'm going to solve for x. So I'm going to say, I'll say that I'm doing that. I'm going to find x, and then I might note that I'm going to find it by using equation 3. So find x with 3. That would be 4x minus 3. We know that z is 1 now, so I'm going to put in a 1 for z, equals 13. Adding 3 to each side, I'm going to get 4x is equal to 16, and x is equal to 4. So I've got this is now my x coordinate here. X is 4. And then I'm going to find y, of course. So I'll just do that right here. Find y, and I will use equation 1 to do that. So I will have x, which is 4, plus 3y is equal to 1. And I'm just going to skip ahead here and say y is equal to negative 1, right? That'll work for that equation. So those are that's my solution. My solution is the set of coordinates for negative 1, 1, and that'll satisfy any of the three equations.